By the end of this module, you will understand the specific technical and operational reasons that make cellular the right choice for a large class of IoT deployments. Let's set up the comparison by looking at three wireless families side by side. Range is the most obvious differentiator. Wi-Fi typically covers 30 to 100 meters indoors. BLE has a similar range, sometimes stretching to 100 meters in open air with BLE 5.0. Cellular IoT, on the other hand, operates on licensed spectrum through carrier infrastructure that covers up to 10 kilometers or more in rural areas for technologies like NB-IoT. If your device is deployed in a field, on a highway, or in a remote facility, Wi-Fi and BLE simply cannot reach a gateway. Infrastructure independence matters too. Wi-Fi requires a local access point connected to the internet. BLE usually requires a smartphone or gateway within range. Cellular devices connect directly to the carrier's network infrastructure, so cell towers that are already deployed and maintained by the operator. This means you do not need to install, power, or maintain any local networking equipment. For a utility deploying 500,000 smart meters across a region, this is a decisive advantage. Reliability and quality of service are another factor. Cellular operates on licensed spectrum, which means your data transmission does not compete with your neighbor's Wi-Fi router, baby monitors, or microwave ovens. Licensed spectrum provides predictable, interference-free communication, which matters for applications where data delivery is critical, like a medical alert or a safety sensor on industrial equipment. Mobility is another consideration. If your device moves, whether it is a vehicle tracker, a wearable, or a shipping container, cellular is the only option among these three that supports seamless handover between base stations as the device travels. Wi-Fi roaming exists, but is designed for building-scale movement, not highway-speed travel. BLE has no native mobility support. Security matters as well. Cellular networks provide built-in mutual authentication between the device and the network using the SIM card. Data is encrypted over the air interface by default. While Wi-Fi and BLE also support encryption, the cellular security model, rooted in the SIM's cryptographic identity, is more robust and does not rely on the user configuring passwords correctly. When is Wi-Fi or BLE the better choice? Wi-Fi wins when the device is permanently located near an access point, needs high throughput, such as streaming video, and the customer already has reliable broadband. Home smart devices, security cameras on home Wi-Fi, and indoor industrial robots often use Wi-Fi. BLE wins for short-range device-to-phone interactions, fitness trackers that sync to your phone, beacons in retail stores, or sensors that report to a nearby gateway. BLE's extremely low power consumption, even lower than cellular IoT in short-range scenarios, makes it ideal for coin cell-powered tags and sensors. The bottom line, cellular IoT fills the gap that Wi-Fi and BLE cannot. Wide area, infrastructure-independent, reliable connectivity for devices that operate in the field, move through the world, or need to work for years without human intervention. What's the main takeaway? Choose cellular when your device needs range beyond a building, must operate without local infrastructure, moves through the world, or requires carrier-grade reliability. Choose Wi-Fi for high-throughput stationary devices near broadband. Choose BLE for short-range, phone-paired, or gateway-dependent sensors.